deal, but just so you know.
All right. So when we do these, when we solve three equation systems, we can have three options as to what happens, or three outcomes. The first is we can get a consistent system, meaning it works. Okay, the equations work, they will have an intersection. But the first type is independent. Independent, this is how I remember this. They have one solution. Okay, one solution. If you think of the word independent, okay, it typically means that person can stand on their own. They don't need anybody to help them. That's one definition that we would have of independent. So that kind of helps me remember when it's one solution. The other thing that can happen is we can have an inconsistent system, meaning it doesn't work. There are no solutions. Okay, that can happen. And then the third type is still consistent because it does work and there are solutions, but there are an infinite amount. Okay, there could be an infinite amount of solutions. That's dependent, meaning there's more than one. Okay, more than one. So if you have to kind of remember, these definitions, independent, there's one. Okay, standing on its own. If it's dependent, there will be more than one solution. And inconsistent, it will work. Okay, so those are the three things that will happen. We're going to go through one of each type today, at least. Okay, so for example number one, I've already told you this has a solution. It's one solution. It's independent. Okay, it's consistent. So on the right-hand side, you'll see in your notes I've given you steps, and we're going to follow those steps today, and I will label my steps as I go. It'll kind of help us, okay? If you don't want to label your steps, that's fine. It's totally up to you how you do your notes, okay? So step number one, let's read it. It says use equation 1 and equation 2 it should say do elimination, on one variable to eliminate a variable. So take a look, we have equation 2 and equation 1 right there. So what we're going to do is we're automatically going to rewrite those on top of each other. So rewriting equation 1 and equation 2. Okay, so in this whole process, we will do elimination multiple times. We talked about elimination last week. If you look at these two equations, which variable would you like to cancel? Okay, I get an X, I get a Y. Anybody for C? Okay, raise your hand. Well, let's listen to yours here. What's the best option?
We cancel them all.
No. Which one has an opposite sign right now? Y. That's the one that you want to cancel. But it does not have opposite numbers. Do we agree on that? Okay, so if we look at Y and we want to cancel out Y, what do we have to do before we can cancel? Distribute a 3. So we're going to take this bottom equation and we're going to multiply everything in that bottom equation by 3. That will make it so we can cancel out our Y. So to make it easy, I rewrite my first equation. The first equation will stay the same. My second equation, everything gets multiplied by 3. The first equation stays the same. Second equation, everything is multiplied by 3. Now that we've done that, we can create our addition problem and add down. Okay, so you should end up with a 2-variable equation. 7x plus 7z equals 28. Are we okay on that? Okay. Step 2. Use equation 1 and equation 3 to eliminate the same variable. This is one of the most important parts of this whole process. If you eliminate a different variable in step 2, this problem will not work. You will not be able to solve it. Okay, so what you want to do is you want to choose the same variables. So we're going to do equation 1 and equation 3. So rewrite equation 1 and equation 3 right next to each other. In step 1, what variable did I cancel in step 1? Which is my red step over there. I canceled y. Here I have to cancel y. It's one of the most important steps that most people make a mistake on. Okay? So here we have to cancel y. Is y ready to be canceled right now? Yeah, which is a beautiful thing. It's really nice. We don't have to multiply anything. So we can go ahead and add down. Any issues or questions on that step? Take a look at my answers for step 1 and step 2. Do they have the same variables in them? That has to happen. Okay? So the point of canceling out the same variable is that you have the same variable. And in order to do step 3, that has to happen. You with me on that? Alright. So step 3. On to step 3. It says use the 2 variable equation and solve for 1 variable. Guess what? You're going to do elimination again. Okay? So I'm going to take these 2 equations and I'm going to combine them into one problem. So I'm going to put them on top of each other like we would do for an elimination problem. Are they ready? Are we ready to eliminate a variable? Not quite yet. What do we need to do? Okay, say we want to cancel out the x's because they have an opposite sign. We would need to multiply this row by 7. So keep that top row and then multiply your bottom row by 7. Once you have that, you can add down. So step number 3 is exactly like a problem that we were doing last week. We had 2 variables, we canceled out so that we can get 1 variable, and then we'll do substitution. So I'm going to divide by 14. So I have solved for z. Z is done. It's ready to go. Okay, any questions for step 3? Okay, step 4 says back substitute to solve for the rest of the variables. So I want you to make a note here. Okay, you're going to substitute into a 2 variable equation first, and then you will substitute into a 3 variable equation. Okay, just make that note right under that step. That will help you kind of remember if you have to go back and look at it. You're going to do substitution with 2 variable, then you do substitution with 3 variable. Let me show you what I mean by that. Okay, so for step 4. Here's our 2 variable substitution. Okay? It doesn't matter which equation you use, but you need to use one of the 2 equations that you got from steps 1 and 2. Okay, so I'm just going to use this one since it's right here. Okay, I'm going to take one of those 2 variable equations and I'm going to plug in the variable that I already got. So I'm going to plug in z. plug that in, now I can solve for x. Okay, and I'm doing that pretty fast because I know you guys already know how to solve. Okay, you know how to get a variable by itself. Okay, now for our next one, we're going to do our 3 variable substitution, which is pretty self-explanatory. And we're going to take one of those original equations. I'm just going to use the top one. Okay, I'm going to plug in what I already have. So I have z and I have x. Okay, now the only variable that should show up in that equation once you've done your substitution is y. I'm going to let you go ahead and solve for y by yourself. Are you getting y equals -2? Okay, so we are done. We have our answer. Here's how we write our final answer. Just like you would write x comma y, you do x, y, z. So x is 3, y is -2, and z is 1. So that's how we write our final answer. Okay, are these problems long? Yes. Okay, but the good news is every single step is the exact same every single time. So you're always going to do eliminate, 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 substitute every single time. Question for me? Okay, this is consistent. This is that first type that we talked about on that first slide here at the top of your notes. So it has one solution. All right, example 2 is a 1 solution problem. We're going to do this step by step, and I want you to do the steps. Okay, so go ahead and do step 1 first. I cut the steps there on the side for you to kind of guide you. So go ahead and do step 1, where you do elimination with equations 1 and equation 2. Okay, so go ahead and do elimination with equation 1 and equation 2. I'm guessing some of you canceled out Y and some of you canceled out Z. Just because those are the ones that had the opposite signs. So if you cancel out Y, here's what you should have. If you cancel out Z, here's what you should have. Okay, X. Okay. Raise your hand if you cancel out Y. Raise your hand if you cancel out Z. Okay, cool deal. Good morning. Hold on. I had a lot of absences. Hold on just a second. Let me check real quick, Joy. Stay on here just a second. Go ahead and work on step 2, friends. Yes, present. Mm-hmm. Uh-huh. Yep. Bye. All right, there's step 2. If you canceled C, I'm going to do Y up here. All right, that's what you should have for the second equation if you canceled Y. Okay, anybody having issues, questions, you didn't get the same thing, you want me to check your work? Okay, so if you look over here, see, right, I have X and Y left. When I canceled out Y, I have X and Z left. That has to happen for those 2 equations to be able to do step 3. Okay, go ahead and try step 3 on your own. Take those 2 answers you just got, do elimination of those. You may have solved for a different variable. Even if we've done everything the same up until now, here I chose to multiply by -5 and cancel z, and I solved for x. Here I chose to multiply by 6 on that top, or that bottom row, and cancel x. Maybe you canceled y. It's okay, we should still get the same answer at the very end. Okay? So that's what I did there. Now, that's step 3. Okay, step 4 is where we back substitute. What's our first type of substitution? What's our first type? Yes, 2 variable. Okay, then we'll do one of the 3 variable equations. Go ahead and do that. Okay, take one of your 2 variable equations and plug in what you've already solved for.
We're doing numbers. Yeah, you're right. We're going to get there though. So this is going to be. We'll go ahead and get it. I'm doing a second box of tissues, and like, what have we got? 2 after school? Here. Should get 1 for z. Oh, no, that's good. Okay, make sure you do both substitutions here. I'm only going to do it on one page since basically do the same thing over again. That should be your final answer at the very end. X, Y, and Z. Any questions? Yes?
Where'd you get 2 plus y minus 1?
That was the very first equation that you were given. I just went ahead and plugged in the, so that's the equation that I plugged in 2 for X and -1, or 1 for Z. Any other questions? I know that these are long. I know, these take a while. Good news is they're the same steps. So that's the best part. Okay. Anything you need me to check and you're just not getting the same answers? Okay. Good news is we only have examples 3 and 4 left. And 3 and 4 are a lot shorter, which is nice. Okay. I'm going to show you example 3. Let's figure out what happens here. This is an inconsistent system, meaning we will get no solutions here. We will not have a origin point at the end of this. And I'm going to show you what this process looks like. Take a look at your original equation. Is there an equation that looks a little bit different? Which one? The third one. What's different about the third equation? We're missing z. Yeah, I want you to think about your process. Don't we always aim to get an equation that has 2 variables? Right? Like in step 2 or step 3? or step 1 or step 2. So we're going to be able to skip step 2, which is really nice. Okay, so let's go ahead and do step 1. You're going to do elimination on equations 1 and 2. But before you start, what variable do you need to eliminate? How do you know? How do you know that you need to eliminate z? Right here. Look. Okay? It doesn't matter what you're given. It just so happens that they're nice to eliminate. But in this equation, you don't have z, meaning you need to eliminate z in the other equation. Okay? So go ahead and eliminate z with those first 2 equations. Okay, you did the same thing with step 1? Okay, so take a look at step 1. Step 2, don't have to do it. Okay, we can skip it because the third equation is already only 2 variables. We can cancel out z. Are you tracking with me on y? You okay on that? Okay. We can go ahead and go straight to step 3. Okay, so step 3 is where we take this first equation from step 1 and set it up with step 2's equation. Okay, and we do elimination for those. I'm going to let you do that. Go ahead and do elimination for step 3.
Are you allowed to eliminate numbers in the original?
Well, that's a great question. Okay, it doesn't matter what you eliminate in step 3.
It has the same
Yeah, it's going to happen. It doesn't matter. You have to. Right? So if you try to eliminate x, you're automatically going to eliminate y here. So if you want to look up here, okay, it should look weird. Okay, it should happen. So what you're going to notice is your x's cancel and your y's cancel, which means you have 0 on the left-hand side when you add. When you add on the right-hand side, you get negative 12. Is it true that 0 equals negative 12? No. Okay, take a look at your steps on the right-hand side. Okay, we have these 2, false statement and true statement. Well, we just said 0 equals negative 12 is a false statement. So when you get a false statement like that and that happens, automatically it's no solution. You're done. Okay. You just right. Once that happens, just see, I should be able to see when you do that count. 0 goes under 12, no solution. We're going to go to example 4. Okay, example 4 is one where we get infinite solution. So I'm going to show you that process. It's also a shorter process, which is nice. Okay, but everything starts out the same. Okay, so first step, you're going to eliminate using equations 1 and 2. This is our last one. Bear with me, guys. We're almost done. I promise. Out x in step 1, I'm guessing you did the same thing because it was already ready to go. We agree on that for step 1? So in step 2, I need to cancel out x. So I'm going to multiply the top row by what? -4. I'm going to put it up there so you can see it. Oh. Because that's race. Wait. Okay, you should get the same equation for that 3 steps there, step number 2. Okay, and if you look at both of them, they both should have y and z. You didn't get the same thing on number 2?
I just multiplied 1 and 6 with y equals.
Okay, here, remember y and z.
Very important step. You have to make sure that you cancel x in step 2, since we canceled it in step 1. It has to be the same variable. Okay, now I want you to watch very close here. Okay, when I do step 3, I'm going to put my 2 equations that I just got together. Okay, it doesn't matter what we cancel. What would you like to cancel? What do you want to cancel? Z? All the above. Okay. Let's just say we multiply this top row by -3. It doesn't matter which one you want to cancel, you're going to have to multiply by -3. So, I'm going to rewrite my top equation. Or I'm not rewriting, I guess I'm multiplying, whatever. Alright. Okay, now, you should notice, I multiply my top row by -3. My bottom row stays the same. If you look at them, cancel, cancel, cancel. 0 equals 0. Is that a true statement? That means it's infinite solutions. Okay, so the difference between it being no solution to infinite is that statement. Either 0 equals 0. If it's 0 equals another number, then it's false and that's no solution. But this case is infinite. Okay? Don't worry about that last question. We're going to do that last question to start class tomorrow. Okay, so bring this back with you because this period is yours to hang out.